Hello everyone, welcome to the series of lectures on Monte Carlo simulation. I would like to start with normal distribution and how is it implemented in Excel. Right, I am assuming that all of you know about normal distribution, and if you don't have any idea about what normal distribution is, you can refer my previous lectures on that. But before jumping into this, I would want you to understand what is necessary for us to learn this. The basic criteria being, in any simulation you have a particular variable which changes based on some randomized value. So that randomized value can be actually plotted using a distribution. Today that distribution that we're going to see is normal distribution. There are various other distribution including binomial distribution, Poisson and things like that. We're going to see how in Excel we can create normal distribution curve using two function, which is norm s inverse and random. Right, now there is a lot of theory about random numbers in itself. You might know what a random number is. It's generally it's from a predictive function, but it gives you a completely randomized value. In Excel it is called RND with open brackets with open function, and in VBA it is RND, in Excel it is RAND. So that's what I have used here in this. You might see that this generates a value. So let me just try to use this function here. So if I say RAND with open brackets and close brackets, it will give me a value which is between 0 to 1. So that's all it does. Randomized function is a separate section in itself, and it deals with a lot of functions of how to generate. Just think for a while, how do you generate a function, or how do you write a function which will give you a number which is completely random? For this theory you might want to read up my article on random numbers in my site. So let's just go into the details of what a standard normal distribution is. If you see from this figure, right, what I have here is a simplified standard normal distribution and its cumulative curve. So what is a standard normal distribution? Standard normal distribution is something which has a mean equal to 0 and standard deviation is 1. Okay, now what is a cumulative curve? You see that the area under this standard normal distribution for any particular value. So what I have plotted here for certain value of x, where x is equal to 0.8, I have an area under on the right hand side of this curve which forms 20% itself. So all these areas can be marked in a cumulative curve. So it starts from infinity and it goes on until 1, but it never touches 1. So if you see this, it crosses at 0.5 and it goes on until 1. So this curve is what we are going to retrace it using the normal S inverse. So what it means is, I am having, let's assume that in this particular figure I am having a value of let's say x being 80. So in our case, let's assume that the random number has generated a value of 0.8. so now I need to find out what is the standard deviation in this normal curve which will get me to the value of x is equal to 0.8. So if you see this, the normal standard deviation for that value is 0.8416. So this is what is being plotted in this cumulative curve. So what you're going to do is, so we're going to take for that specific value of x. So if you see the graph here, the value of x is in the x-axis, and you have the distribution value in this in the y-axis. So now I can find out the corresponding value which gives of x equal to 80 in d of x. So that is what is the area. The area under that curve would be got from this entire portion in itself. So all the value that is over here, or the area that is here, is marked over here. So given the area, what will be the value of x is what you're trying to find out using this. So I am simply using the random variable concept or random variable function to generate a random variable, and I am finding out the normal inverse function of that. Right, so let me repeat what I've told here. So we are trying to find out the usage of this norm s inverse function in Excel. So if I have a value of x is equal to 80, that is 0.8, which is generated by a random variable, we need to, what this normal inverse S inverse would return to us is a standard deviation that is required for either 20% on the right side of the curve or 80% of the area on the left side of the curve. So let's go and find out what is the value, whether the value that you got is correct using normal function. So I have NORM S inverse of, let's say, 0.8. Now the value that you might be expecting in this is 0.84. That's what we have got, that's what I've written here, a standard deviation. So it returns a standard deviation that is required to find out 80% of the curve area under the curve on the left side or 20% on the right side. So it means the same thing. So I have the value of 8.8416, which is exactly what I have written here as well. So yeah, now let's go ahead and understand how to use this function for a simulation in itself. So you see that the value of the random variable keep changing. So for every time I click an enter or an F9, so that essentially is a program random which will populate various values. And if you see that the standard normal curve itself cannot exceed, the lowest value is -4 and the highest value is 4, and that is what I have tried to mark in the count of and the max and minimum value here. If you see this, if the moment I press F9, values of this function random, but none of them would actually exceed 4 in itself. So that's essentially the point, right? So I can find out various values for this particular simulation, but I can have the maximum value as 4 and the minimum value will also be -4. So what I've done here, I've used this function norm as inverse of random number. So it simply gives me the list of normal distribution values or the standard deviation that is required to have the for the particular random variable that is generated. So I have generated 1000 values here. What you're going to see is whether we are able to generate a normal distribution curve with Excel random function. So I have categorized for my frequency distribution, what I have categorized is from -4 until 4. I've categorized them in steps of 0.2. So let's find out the values or the number of counts for this in this 1000 normal distribution, where points where I have to find out whether it is actually following the same way as the curve, so as the normal curve. So let's go and find out that. We have a function called frequency in Excel. So it is actually an array function, so I need to select the entire set where I need to get the values of the frequency. So I'm trying to find out that value here, so it will become frequency of the array, that is where I have the data, that is column I, and the bins basically the categories over here. So let me select the bin array where I need to categorize the entire set of values. So if you see this function will give me in a nice pictorial way whether it's possible for me to generate a random function. So I have to enter Control Shift Enter. For this it will populate the bin values and the frequencies. So let's go ahead and draw this in a histogram, or scatter plot. We will see that how this particular plot or this particular value that you have got matches with the normal distribution curve itself. So I'm having a scatter plot for this values. So let me select this. I've removed this, and I'll select along with the bins the category and the frequency. Only then I'll be able to plot it in a scatter. So this will give me, let's see how well it actually fits into the normal distribution curve. Right, so if you see this, what I've got here is a scatter plot which more or less looks like a normal distribution. So let's bring it to the top and see for what values we will be having this particular distribution. So if you see this, it closely resembles more or less the normal curve that we have. but then we can say that obviously there are various reasons why it is not happening the same way as a normal distribution, because for number one, random variable, although it's a function, it's generally a pseudo random variable, and number two, since we are using normal distribution, whether how far we are going to replicate is a question always. So what we've learned here is to use norm s inverse and random function in order to generate a scatter plot, or probably a standard normal distribution curve itself. So two very key learnings here. One is, okay, what is norm s inverse? To reiterate, it gives you the value of for example, if x is equal to 0.8, it gives you the value of the standard deviation that is required for 80% of the area on the left side, or 20% of the area on the right side. And you also know what a cumulative curve is. So the area under these curves for various values of x is plotted in a cumulative curve. So I can, corresponding for 80%, I'll have a value which is the area in itself, so from a standard normal curve. With this, we'll try and stop the class today. We will come back for more distributions, and then we'll see how that can be used in our Monte Carlo simulation. Thanks a lot for listening.